is the list of the summary, like the average income, the median, to cover several topics. Example, this is the data processing package library in now I try to plot this word file to generate something to it. So let's come back to the core of the course topic. It's called business analytics. And sometimes we use different words interchangeably, like sometimes we call it operations analytics, which might be similar or slightly different. So the natural question is, what is it? Let's try to define it and understand it better. So in order to do this, we ask you, what is business analytics? And the answer is quite long. We will try to characterize business. Actually, this is very defined. This is the answer of analytics. And this is exactly the same. It matches perfectly with the concept that I'm going to talk about. So let's forget about this long paragraph. Sometimes it's also very long, but it's not necessarily. So the analogy from philosophy. Let's first think about three philosophical. I'm not trying to teach you philosophical concepts, but let's think about it for a while. This is the three fundamental philosophical questions all of humankind should think of. Right? Where do we come from? What are we? Where are we going? Actually, in Boston Museum of Fine Arts, there was a painting trying to picture the three philosophical questions. Well, I'm not here to answer the philosophical questions because I don't know the answer. However, I can give the analogy to answer the question of what is business. So there are three parts, right? First one is where it comes from. So if you think about in the business analytics perspective, around 30, 40 years earlier, we start to have more data. So the need or the tendency at that time was to summarize data. Think of yourself as a business analytics. The boss throws a data package and asks you to generate whatever a report or summary statistics, summarize the data. So what you can do is you cannot just throw all the numbers, all the details, rather than all that. So that's why we develop all the techniques for summarizing. This will answer the question. Once you have fundamental of data, where do you start? This will do things. If you're a data and if you're how to cover the data. And gradually, we summarize the patterns in data. We are not satisfied with that. We want something more. And we are trying to answer the question to the next stage. Take the analogy of this. Think about this process and we are 100 years ago NCR. We are trying to, based on observations on our real life apples around, we are trying to explain what we observe by fundamental steps and patterns. So this is what we do. You could call this predictive analytics, and it's very, very, very large number of patterns in my profile. Very possible. Essentially, what we are trying to achieve is that is build up a model, or at least trying to explain how the data is being generated. We are trying to investigate the pattern behind the data. And this is called insight. But we are not done yet. We can argue that in the past 20 years, machine learning might be the topic. But I'm here going to claim that we have one step further, right? After you build a model, after you are able to explain the data, what you can do with it, that is ultimate. Where I was going, right? So I'm from the field of operations management. So sometimes we take size of our field because of the reason. We are doing one step further predictive analytics. Once we understand how the system works, once we understand how the data is generated, it will help us to make better decisions. In other words, optimization. So here we use the word optimization. The optimization actually varies, and sometimes we use this. And this one we talk about. So from the past to the future, from the past to the current, present. But eventually, so once we have about business analytics, summarize or try to understand better the data, sometimes we need to build a model, and eventually we want to provide better data, better for them. That is roughly speaking the analogy of the philosophy. I hope it's slightly easier. So now if we go back and revisit what the GPT is providing us as a answer, we now have a better understanding of the three components: descriptive, predictive, prescriptive. And of course, GPT is trying to be helpful. Usually, it will give you a lot of examples and application domains, which will see and it will summarize. Business analytics turns raw data into insights and insights into better business decisions. It's supposed to be a smooth process into stage of reach. You may think, okay, in recent years, we have more and more data, so like say that very always one papers, right? So like that, okay, thanks. Theoretically, one thing. This way, once again, fact. Sometimes when you investigate data and try to solve it, you can actually compare yourself as a from the regularities from the metadata involved to find out the pattern and help you who is the output. Another very old example you probably don't know is he was released as one of the founding research possible like that. What we talked about. So this will highlight how important data. Well, if you think more closely, the past 10 years have bigger challenges in terms of the data quality. Previously, when those people talk about data, it's only numerical. So to deal with those numerical issues, people usually develop statistical tools, machine learning tools, and so on. But if you think about the format of data in the past 10, 20 years, the format is becoming more and more informative, and of course, math. So not only numerical data like the number of products involved, their features, the codes, but other formats like the text, like posting red, video, images, voice. So if you think about the information contained in a single text, including all the pixels, image, including all the pixels, it's not comparable. You think about the number. So this poses new challenges for the field of like researchers and practitioners. How do we deal with it? Fortunately, we have all the newest machine learning tools, including like computer vision tools, and of course, large language models. This will closely connected with why large language models. And we have time at the beginning of this lecture, I was briefly. Let me pause here for a little bit to see if you have any questions about the course, about me, or about the introductory topic. Yes. Oh, I not specifically the content of that course, but the second data lab. I do. So if you take a closer look, very good question. If you take a closer look at some of the potential topics that we're going to see in this course. So during the first maybe 6 weeks, we're going to see Excel, and those are pretty fundamental. Again, I may not be 100% sure what the other courses we're referring to, but even if some of the topics have some overlap, I believe because it's individually prepared by different professors, I believe the use case and the data set we prepare should be different. And also, I'm not sure. I don't think the IS course will use some of the, for example, like power theory. Again, I'm not sure, but if you want to do more, we can do more. How many of you are also taking that course? Really high? So okay, some of you. So you're all from the AI program. I will find out more. We have a lot of apps. Like stuff. Very good. Oh, I was just thinking, trying to explain why we can observe some attempts when I said stuff. But it's not very likely to any task. And either finish it itself or type. It's very rare for it happens, but it's not very common for us to make a task that will require both Excel and Python and integrate together. Dividing we can by increasing this tool, it's now by Python. But it's greater, but it may not be that because it's also by Python. doubt, especially because the different classes, any general questions about local distance, I think it's best fine. So now we spent a little bit of time talking about systematically some concepts. But first, I want to do a recap. Remember, the first step is analytics. We're trying to summarize what we have data set. And the following mathematical concepts, I believe all of you have learned already. So first, we have a messy data set. First thing that comes to mind might be data set for the numbers. Again, here we only need to do so in terms of the summary statistics, there are a lot to talk about. And the first one, and most commonly used was measure statistics, which includes the three order: mean, average, median, and slope. So think about an example of weight or income to a leader in the data set. So if I give you a data set which contains thousands of people's income, and I want you to draw some conclusion observational insight from the data. The first thing that we can think of, naturally speaking, is the list of the summary statistics, like the average income, the median income, and the mode. And they all represent different meanings. As you can see in the plot, if a distribution, if you draw a histogram or something, if a distribution is symmetrical, then all of the three summary statistics will be yes. If it's not symmetrical, sometimes we got skewed, then there will be different. So if you think about income is definitely not symmetrical. There are some people in the world are surprisingly rich, much richer than we can imagine. So that's why it is a direction. And that's why in terms of mean, it's higher than the others. Why? Because the extreme rich people will drive the average value. So this is mean. It's the most widely used summary statistic, but it's often being influenced by the extreme value, like the extremely rich people and extremely poor people. Median, on the other hand, is more robust in a way that we only think about the 50%. If I have the median income, that means there are exactly 50% of the people in the world who are richer than me, and exactly 50%. Mode is the other perspective, stating that, okay, if we count people of different income, mode is the most frequent observation. So we have the largest subpopulation in that level. And the power of such measures of censor comes from statistically speaking law of large numbers. So again, we borrowed the code from almost one stat. You can, for example, never foretell what one man will do, but you can say with precision that an average number of individuals vary, but sophisticated. Again, what does it mean? It's not an application, but we understand our way is that for individual data points, you could not tell that all we can predict how individual person will behave. But once the data size becomes larger and larger, we can go to average change. And of course, sometimes when we talk about distribution, we not only talk about the centers, like the green. We also care about extreme values. Like people love to talk about the richest quotes, like that's the maximum. And the minimum is also very important because in the US they have minimum wage regulation, right? So maximum and minimum both are very helpful to finding someone. And of course, we have other measures apart from the center, the extreme. We have standard deviation and variation that will help us measure spread. The larger the standard deviation, the more noise, the more obfuscation data set. I believe these are all very standard. I'm not trying to use mathematical terms to explain all these concepts. Roughly speaking, whenever you take the data set, and from those numbers, you get a better understanding. And that's not all. If you want to know more about center and the extreme and the spread, sometimes you also care about the sometimes. Percentile and quantile are useful measures to care about certain levels. And median is a special case where it is 50% higher. Quantiles is 25% percentile and 75%. And if you are interested in other percentiles, the reason I'm introducing this quantile is that later the box plot want to interpret what value is three quantiles. Here, for example, for different distributions, the position of the three quantile values will also differ. Here, Q2 is the second quantile, which is also 50%. So it's more spread, most readily distributed like a uniform distribution for three compounds will also be better. If it's more center distribution, the compounds are close, like a normal. It is worth mentioning that we have a term called IQR, interquantile range, which is the difference between the first and the third quantile. Intuitively speaking, this interquantile range captures the middle 50%. The range, the interval, the distance will be reflected less than twice. So this is the typical box plot. And sometimes it's called a box plot will take a box plot, which is characterized by interquantile range. It represents that it's the distance between the first quantile. And the line in the middle represents mean. Some box plots will also have a little cross that represents the mean, which can also be helpful. Outside the box, if you take the third quantile plot 1.5 times the interquantile range and Q1 on the other side symmetrically, Q1 minus 1.5 times interquantile range, we get line segment that will cover the box. Well, naturally, because naturally, actually the set up. As we say, when we have a data, we don't know what the distribution is and how much it is. But normal by the name, they are the most common. So if the behavior is normal, then this box plot will have a give us IQR for the box. And if certain observations are without line segment, they are either smaller than 1 minus 1.5 IQR or larger than 1.5 IQR. They are both outliers and they are visualized individually. Each observation. As I explained, the reason why we are using this particular measure for a box plot actually came from the assumption for the indicated movie distribution might be known. Because in the normal distribution, the quantile plus minus 1.5 IQR will capture all those. The normal distribution captures all those line axes. So we can see that any observation that is ordered requires that all of the outliers and the plot. They are not really like. There are things ways to careful. And again, those numbers like 1.5 are numbers like 0.35%. You don't have to mesmerize. But they are from certain rules they have inside. There are other rules probably have certain. Again, the analogy of a normal distribution. And again, we are trying to characterize the distribution by using standard deviation. Sometimes this is called a again, instead of capture the middle 50%, capture plus minus 1%, which according to normal distribution, we capture about 2/3. With plus minus standard deviation, roughly speaking, it will capture 95%. By the way, 95% is difficult threshold. And Six Sigma, which is plus minus the standard deviation, will capture more than 99.7%, which is typically speaking more than usual. And anything beyond that are extreme outliers. And from this, we can know once we use some summary statistics, we can combine it together with some data visualization tools. For example, in Excel, later we will try to plot this together. It's very convenient for us to make a box plot like this, or a histogram. We'll plot all of this together using the weight data set, or a scatter plot. So to do this, if we have it down, so we go to canvas. There's a Excel file called needed or weight. Take maybe another 30 seconds to make sure it's downloaded. Once you download it, it's probably in the download folder. It's the first lecture, so eventually you will be having your directly from Excel to the file. But you now find where Excel is. Excel is the first one. How many of you have it? Okay. Okay, they are. So that's why you really start from very, very beginning. Anyone access these files after average file? By the way, we also uploaded the syllabus. So if you want to take a through the notes, mainly about the information we talked about to go through in the slide. But if you want to have a closer look, for example, the detailed components for each reading criteria, you can take a look. So for those of you who are new to Excel, again, let me try to slow down as much as I can. Excel is supposed to be sometimes we call it spreadsheet. It's supposed to be a multifunctional, like daily data processing tool, which is supposed to be very user friendly, at least compared to Python. You don't have to write usually speaking, you don't have to write code, just to typing and dragging. And on the top, we have all the ribbons or the menus, and on the bottom, we can have these tabs. Right, that's some fundamental introduction. And here, I enlarge the window so that it's easier for you to see. This panel is particularly useful because we are going to type in a lot of functions. But let's not talk about that. We have plenty of time in future lectures about detailed operations. Let me first introduce the data. So again, the data only has 5 columns. The others are things that we are going to do, summary statistics. This is the most widely used data set, historically speaking, from math. When I was a PhD student, I learned this data set. So people love to tell the story. The story is called Return of Schools. Basically, historically speaking, I think this was like more than 30, 40 years ago. A group of econometricians collected data set. More than 500 employees in terms of their hourly wage. This is in terms of US dollars, their hourly wage. In other words, their income. Their years of education, their years of working experience, indicator of their gender, and an indicator of whether they're married. I will try to explain one by one, but before that, on very high level, whenever you are thinking of data set, the first thing is think about whether the format is standard. By standards, usually speaking, by standards, at least in Excel, we mean that each column is a feature. Each row is an observation. So again, let me repeat. Each column should be a feature. Here, like income, education, there are different aspects, there are different measures of the people. And different rows are but different. And note that the data can have different formats. The first three columns have different formats. Particularly, the first three are very general. Yeah, that's and more specifically, week. Educational year. Here's education year. That's it. Nice. But they are fundamentally different than the others. We can think of the other two columns as either categorical or binary. Categorical variable is different than numerical. It usually only takes a set of discrete values. For example, if I ask your favorite color, the answer will not be a value. Instead, it's one of the many options. So similarly, whenever we are facing a categorical outcome, it usually comes in as either a text or something similar or a fact. Among the categorical variables, there's one special case which we love. If your answer can only be 2, if I ask your favorite color, of course, the potential answers are definitely more than 2. If I ask you a question that you can only answer by yes or no, that's a simple 0, 1, and we call it 5. So the last two columns are this kind of special categorical variable, or we can call it binary variable. For example, if I ask the gender of a particular employee, so we know that the gender tends to be more than 2, but here, at least in this data set, we only have 2 genders. If the answer is 1, if the outcome is 1, that means for that particular individual, we have a yes answer. So again, on a very high level, the first thing you open the data set is to see whether you can understand whether the format is consistent, that's the first, and then whether you can understand each column correctly. Because without correctly understanding the data, you may draw sometimes inaccurate or even wrong conclusions. For example, if I send you this data file directly without explaining each column, maybe you can guess, right? We have the term wage, but there's no way for you to know the full information. Like I'm telling you, this is hourly wage in US dollars, which is not explicitly written in this data. So in your future work or study, whenever you are dealing with a data set like this, whoever providing you the data set will also provide you with the data set, which will explain in detail what does each column mean and what is the background and context of the data. At least for macro values, it tells you this addiction. What are US dollars? This is here. Without knowing that, we can. What are these 11 to use? So that is very important. This data set is simple, and I'm here to telling you, so we don't need a data set. But in the future, when we are facing more complex data sets, we may really need to do. At least some side problems will be covered. And again, another side note when describing a data set is remember the categorical variable I was talking about, right? One of the most frequent is to convert categorical variables into lines. Like, statistics are very simple. But us, a person doing the survey, gender, or the marriage state, they often only get outcomes. But think of another column where I say categorical, where the author has to. Then, for example, I'm asking the favorite column of the person. Then the answer has more than two options. The data will become a little bit messy, right? You can imagine a column that is either numerical or binary, 0, 1, will be consistent of text. Red, green, blue. Most common way that we deal with those kind of categorical variables is you go out. Let me give you another example. In recent years, the text because colors, I cannot enumerate all the colors, but for text, we know there are, correct me if I'm wrong, 16 types. So if I have a data set that contains the MPI information for importing, we know there can only be 16 outcomes. So how do we convert? And each outcome is a text, right? How do we convert the text categorical column into a 0, 1 binary variable? Some of you may be already very, very familiar with this, which is very fundamental, but for many of you, maybe quite new. The answer is that we, instead of a single column, we create 15 more new columns. Each responds to a binary answer to whether you belong to a specific MPI. Is that reasonable? Again, because I'm a little bit less familiar with your background, people here have different backgrounds. Some might find this particularly positive, some find this. So I try to ask more questions. You can tell me why. Depending on the answer, I have a better understanding of the text. So again, let me repeat my example. I'm going to have a column which consists of 16 different outputs in text or in text. Now I say, okay, this is not convenient for us to deal with because 16 is quite a long number. What we can do instead, convert them into something like this, a binary outcome, is that don't use that column anymore. Instead, create 50 more columns, new columns, which consists of 0, 1 binary. And then all the data will become binary. So 0, 1 is a now who can see the answer? Why? Yes, louder. Louder so that everyone can hear. Let me try to say that is our construction. Well, that's a good guess. So maybe let me put this question in this way. That's a good guess. That's a good guess. We'll try to revisit the answer. Let me put the question in a different way. Here, for the gender, we say, you can think of gender as a categorical variable. But in the end, I only need a single column for gender. So 2 becomes 1. This is exactly the same as 5, 16 becomes 6. Right? So the reason is that we know there's only these outcomes for gender. So 1 column is enough because my answer is 1. I know I'm a female. Then I cannot be a male. So if you have an actual column, for example, we insert another column as male. So standard speaking, we also add a male. If 1 for male, then it must be 0. 1 for female, it must be 0. So it turns out this new column is redundant information. We don't need it. We can get the full information by the level of factors minus 1. So again, let me repeat it. For some of you, this might be relatively new. Because categorical variables, factors have n level, here is 2 levels, 2 genders, male and female. Technically speaking, in data pre-processing, and minus 2 outcomes will only be a single column. The MPI category. Because imagine, right? That's for example, what is more MPI? Yes. That's that. I only need all the other types, other than this. I need indicators for the what is each of the remaining 50. But there's no DNFT because if someone answers, well, ask you the question of all the remaining 50 types, you will all answer no. You will all have 15 zeros. Once I observe the data, you have 15 zeros. I know for sure, like, there's no 17 types. can only belong to the type that we did not mention. If I include 16 types, it will be without it. Again, this is the cycle. Not very important, so probably revisit sometimes. There's a basic difference between numerical and categorical. And the bottom line is that at first, categorical larger number of binary numbers. Back to the data set. Why is this data set important? And why, historically speaking, econometricians love it? The reason was that, like, people love to build models to explain the so-called returns of school. Well, you might be interested as well. I don't know the last graph, but it took me 6 years to finish my thesis. So naturally speaking, on this, right? What you wrote in the master program, you will want it. We don't, right? But actually, you spend more time in terms of this one. Which really means that you spend less time in your work. Well, that's something so individuals cannot see this, right? Because each individual has their own plan, has their own preference. But beauty of business analytics or that really a small number is that once we collect enough data, 500 still may not be enough, but enough for us to identify. So again, this data set is very old. Whatever we take that obviously will stay. But still, average. Let's think about what summary statistics. So for the first 3 quarters, again, let me explain the wage, hourly wage, US dollars. Here's some analysis. So matrices want to develop a hypothesis saying, okay, for example, the longer years of education will lead to higher wage. Which, again, for individuals, it might not be. But statistically speaking, quality is 95%. So let's just basic number of operations. Here already we everything. This is the table we made. All these processes, services. And these are 3 columns. So start by counting the number of observations. Again, considering that now I see there are a few number of people who have never used Excel before. Let me quickly show you. So again, this is called a formula bar. Whenever you are trying to not straightforward type in number function, and the way to insert the function is by you cannot follow. After the equal sign usually is followed by a function name. Most of the functions are the reason I would say that Excel is very good to preparation is in many ways, or this is one of the reasons. When you try to type a name of a function, you not have to type all the for example, if people try to get, for example, count after typing the 3 letters, we know we will get the function we're looking for. So here you do not need to finish all the typing. You simply press the tab key to finish the full name of the function. And after typing the full name here, the font size may be a little bigger, maybe a little smaller here, but hopefully you can see it on your own desktop. We will have a side note explaining what's the usage of this particular function. For example, the function count will count the number of cells in the range that we can. Usually speaking, after the function name is followed by a set of traces. And within the brackets, they are supposed to be required. So here, we are going to select a region that will consider number of things. And we can do this by directly typing, selecting the whole column. Because the function said earlier, right, it only counts the number of cells with numbers. So you don't have to worry about the weight cell being counted as one. So you can either do this, selecting the whole column, counting the number of cells with numbers, which after you hit enter, will give you 526. Alternatively, you can manually select by select the cell and drag it towards the bottom, which you can see takes a quite long time. I suppose it will give you the same answer, 527. Here, let me see. It's optional because all the properties are optional. If you want to select the range, it's very important because many of the real life data sets are very long. Go down, it may take you a minute. So if you want to select the whole column as the range number, then so by selecting the first cell, then the will automatically put the last cell, last row, that contains value. Similarly, if you want to select a whole code, right, and right here after down key, you will select the whole range of the data. Again, just optional. Another reason we are saying that Excel is user friendly is that after you build the basic step, Excel will try to get copy paste the formula of Excel other things. Excel will try to get what are the updated ones. For example, if you copy paste, I told you what copy paste this. It gets the same. Oh, formula updates from copy paste. Because we are moving one column to the right, Excel understands that if we are extending our range of selected one column, you can either do this by copy pasting, or more conveniently, you can do this by dragging. Dragging is another way of copy pasting. So whenever you want to do a copy pasting for you go to select the cell formula you want to go to the most right order. I know this one. And then you back, right, back. And then you will realize Excel will try to get spread to the right if that's what you want. Because instead of counting the number of values, the A column instead of actually. Sometimes there's drag as you wish. Sometimes, for example, if you drag downward, Excel will try to guess, okay, now this range of selection will also go one row downward. But here we are computing the mean, not counting the mean. So dragging, before dragging or before copy pasting, please make sure that is what you want. And sometimes Excel is even smart enough to figure out, okay, maybe you are making a mistake. So whenever you have a little green triangular shape on your left, this is the left top corner. Basically, it's a hint for you to double check whether you are making a mistake. It's not necessarily you are making a mistake, but it's a suspicion. You need to check. Okay, let's have a 10, 15 minute break and come back around 38, 38. In the meantime, if you have any questions or if you want to let me know more about the background, for example, you are particularly advanced or you are particularly behind, talk to me. Okay, let's resume. So as I said, if you have any comments, feedback, or particularly if you think sometimes either I do the practice too fast, or sometimes from previous year's comments I speak too fast, you can let me know for me to breathe down, slow down a little bit. So let's continue. So you may argue that counting the number of cells is not very useful because you can manually count, right? You scroll down to the last row and you know, roughly speaking, what is the sample size for this data. But all the others you cannot know by taking a look at the data only. For example, we are computing the mean. Let me explain a little bit. Here, at least within the scope of this course, we are using several terminologies in the table. This may appear also in some of your statistics and mathematics course. When we talk about mean, or sometimes when we talk about average, in mathematics, always we talk about expectation. At least within the data analytics framework, we talk about the average. It measures the average value across data. And also the function name in Excel is very straightforward. It's called average. So equal sign average. Again, without typing the full name, you can also show you the function. And with that, you can select the whole column. Or alternatively, you can select only the numerical length. Either way is fine for this data. Similarly, you can drag or copy paste manually by you don't have to type the function name average 3 times. Just drag the using the same function or different function. So as we can see, the mean hourly income of US dollars is about slightly less than $6. Because this again the data set is very simple. We have a rough understanding of the average education here is about 12. And the average working experience here is what they are. On average, everything we think right now is on average. They are on average quite experience. Similarly, we can compute the standard deviation. Again, it's like a variance measure, which will measure how spread out, how noisy the numerical observations are. So again, different purposes, we have different function names. Usually speaking, you don't have to memorize the function name. Just a common one, like average. For standard deviation, the name is called SDDD, short for standard deviation. You can type in. And sometimes for a common purpose, you have different versions of the same function. And for this SDDD, which will fulfill our purpose, but we can also like see a note, see a little exclamation mark here, which means okay, they are like the newer versions of them, which is SDDD, the same function, but slightly different version. Again, we are not going into details of statistics, which I assume you have a basic understanding. We have two versions of computing standard deviation. One is population-wise, the other is sample. So we can try to use the default one, SDDD, and we put down this, which will give us around 3.7. If you are curious of the two variants of SDDD, you can try from S. It will give you the same option, which means that the standard SDDD, it is the same formula for computing the sample variance or the sample standard deviation as if you are using .S. We can also try to if the population standard deviation. This will give us slightly. Again, we're not going into the details, but from the already learned it. The reason of the difference is that for sample variance, there's slight difference. This one cares about practice much more important. And similarly, you can drag the standard deviation for education and for these are all very intuitive, right? Because usually speaking, for a group of people, the variance for the standard deviation for the years of education would be much smaller. Because many people's education history might be similar, but people's working history might be quite different because it's more free, it's more flexible. It depends on people's specific career goals and specific career choices. Right? And similarly, we can use other functions to characterize the mean and the percentiles of the function. We have the function and x, which will measure x of that. We have some extreme observations. Some people that have, well, at least all of them have certain working experience, but for some, they did not receive any education. Within this data set, this is the information we can quickly draw from the summary section. In terms of the 3 quantiles, we will use the function percentile. Again, percentile is a very long name, so what you need is you only need to type the first several letters. So again, by default, because this is our first factor, by default, we can just use the default version. If you want to know more about different variants of this function, one is we're not going to let's just use the default. can manually click on the functions that will require two arguments. So most functions will take, at least one argument or input. And this is the example of keeping two. And Excel is very thoughtful to hint you what should be the order of the two inputs. The first one is array, or you can understand this as data. So the first argument would be the data. So because we are investigating the percentile, so we'll select the data. If you have multiple arguments in a function, they are separated by comma. And the second number is k. Well, if it's the first time you use this function, you may wonder what is k. Turns out you can try. For example, we can try to do. But if you really want to know the documentation, the details of what the input means, you can actually go to insert formula, insert function. Because all the functions in Excel are formally well documented. For example, what are they required inputs? What will be the format? There's different one. Insert functions. And for the percentile function we are using right now, it will explain. Right. Again, the font size here is a bit small, but you should be able to see on your own screen. So it has a quick explanation of what this function does and what are the requirements. This function is available. Returns the key, the type of value. So it requires a range, data range, and it requires a. A is the value. So they have the more detailed explanation. And sometimes you have too many arguments, and your expression of the formula is getting too long. It's actually safer for you to use the separate window, manually select. Like, for example, the first argument in a way, then click on the button, manually select the formula. Which will give us the same result as by typing in the argument. Again, the other two columns, and we will repeat third quantile and right. So again, they should use the quantile, how the first quantile first 0.5. Again, the word quantile. There are two quantiles. One is quantile, one is percentile. Let's talk a little bit about each side. Quantile function. So we have four functions like we split. We arrange the data in order and we split data. The first quantile is exactly 25%. If we convert between quantile and percentile. As explained, the second quantile is 50%. Percentile, which is also. The third quantile will be the first 25%. So the number of the words percent that we provide data is 100. Like 1%, 100. We care about 25 and 75. I witnessed a little bit. Okay, that's a good question. And similar to the maximum value. And we can see the maximum weight is actually much higher. Also, because of the reason I explained earlier, if we talk about income distribution, there are only a few, but very rich people that will drive up the average value. So that the average, if you compare the average value to the median, the average value is much higher. Again, because for median, I don't care about how rich the extreme rich people are. As long as they are rich at least. I only care about the middle. 50% richer, 50%. But for the average, you have a super rich person. You'll see quite average. That's it. And if you think about the most, it's easier to understand that relatively less use. Again, those represent the most frequently observed. This case, again, it's lower than both the mean and the median and what of we have before. You can do the same similar analysis for years of education, working experience, and so on. So after summarizing the summary statistics, for example, the mean, median, mode, and so on, we have successfully screened the size. Again, our primary goal is to report our boss after we have fixed the data set. What conclusion, what insights we get from this? Okay, I made the table of summary statistics. In fact, when I write my academic paper, journal paper, whenever I introduce a data set, it's compulsory for me to write how many observations, what are the means, what are the main max, and so on, 70 days. Because it is important, it's impossible for my readers and for our bosses to take exact loops of all the individual numbers within the data set, but take a closer look at the summary statistics table will help them understand, because we can quickly draw some observational conclusions, like what we did before, right? Like the average. And we often combine this with data visualization. We'll spend some time to talk about more details, what kind of data visualization we use, both Excel and Python. Here is only our first lecture. So I don't have to explain why data visualization is important, because if you have, again, if we're trying to report our loss, even though we have done a great job of reducing the size of data from a large data set to a very small summary statistic, still the loss is not small. Because what? Because visual information is the most effective and most attention. So that's why we should visualize. Also, for another very important reason, because sometimes summary statistics have been misleading, right? You only try to understand the data or the through the summary statistics, like the mean or the average. It may give you a wrong conclusion for the price. For example, if you only tell by the mean weight, it's hard for people to imagine that there are outliers. The complement that became more summary statistics attacks, but still, to a certain level of information. It's not the full picture of the whole data set. That's why data visualization, in this case, is because of many of the data visualization tools will help us visualize or illustrate the data. For example, if I give you this data set, what will be the single important question in our class? Both in this class and before they want to find out what is the return of schooling. In other words, they want to find out, if I spend one extra year in education, not at work, will this increase or decrease my average? Pay attention to the word average. I'm trying to be rigorous here, because we cannot predict exactly for each individual. There are certain randomness that we just cannot estimate. But on average, we may be able to do. So there are different ways. We can use linear regression, we can use machine learning, but the most natural way to understand how it works is through something like correlation or visualization. So here I'm making a plot. This is called scatter. The word scatter means that it's spreading everywhere. So each little blue dot here on this plot represents a single data observation in the table. So by doing this visualization, we are not losing any information. Everything is truthfully reflected on this plot. So if you take a closer look at this plot, you can see there are x-axis and y-axis, where the x-axis is and the y-axis is here. I mean, in Excel, many of the operations are intuitive. So if you cannot figure out how to do it, you can try it out. This is also one of the benefits of courses like this. Again, it's very hands-on, so don't be afraid to make mistakes. In many cases, you can quickly realize you can make a mistake, and once you practice. So first, we select data. Here, we care about the weight and the years of education, right? Whether more years of education will lead to a higher weight. Well, I hope so. Otherwise, the whole education system is unaffected. So let's try to make a plot. We go to insert. There's a whole region of charts. I mean, in Excel, charts basically. And for our beginners, we will just try to use the recommended chart. Let's see how smart is Excel. Can it recommend the chart type that we want? It recommends 4 types, including the scatter part. So we'll click OK. And this will be, again, on the y-axis is the education. On the x-axis is the weight. But generally speaking, in order to draw a conclusion, we sometimes want to reverse. Right? So this is something that we will not explicitly talk about today, because it involves dealing with the theories and changing the data and stuff. And if you have a question like this, before we officially going to learn it, actually you can talk to Google, GPT, or whatever, dot model, Google, counter you in efficient way. So ultimately, we want this plot to be, well, to split the x and y axis. But from this plot, you roughly see something, right? Generally speaking, if I'm talking about correlation, later we will try to compute the correlation. So for those of you who already forgot what have learned in the statistics, correlation measures two data series, or two series of variables or two series of numbers, their tendency. Correlation does not mean causation, but correlation is just means that if one variable or if one data series increase, will the other increase or decrease? So correlation can be measured by a number between -1 and 1. Zero correlation means that if you observe one series going up, you cannot predict whether the other is going up or down. In this example, we would expect that the correlation between weight and education years are positive. Again, otherwise we have a strict problem. So if the correlation is negative, means that if you spend more years in school, I will guess that your income is lower. And again, so again, you have another chance of how to change the plot structure, how to change the plot as you want to. We can also generate other types of plots. So this is the box plot we mentioned in the slide. So let me delete this and generate it again. So again, box plot is even some because it only involves a single data, a single plot. Here we only care about weight. So we select the weight column, like clicking on the A column. And again, we go to insert method market. Unfortunately, Excel is not smart enough. Of all the 4 candidates it represents, but there's no box. So in this case, we have to go to all parts and manually find box plots. So if you go to the list, towards the bottom, there's one option called box and list. This will help us make a box plot. So again, whatever Excel generates may not be what we eventually want to present to our boss, right? Because this is highly cost-effective. We're generating a plot without a title, without a legend, without an action. The action is what is the boss. But here, again, because this is our perspective, this is from the box plot, let's apply what we learned. We can see the box, which is the distance between the first and the third point. We can see a line, which is the median. We can see a little cross, which is the mean, which is optimal here. And the interquartile range, plus or minus 1.5 interquartile range, to get the so-called the line segment range. Or sometimes we can think of this after both of these. And the individual dots are the outliers. For a symmetrical distribution, we would expect outliers both on the left and on the right. But for this weight distribution or income distribution, clearly, there are outliers only for rich people. Because there are so many low-income people, but only very few rich people. So they are the outliers. Some of them are quite far away from even the section. So this is what we can get without compromising any information from the data by visualizing it. Similarly, there's no single correct option to visualize the data. For example, for the weight distribution, you can use the box plot. You can draw certain information from the box plot, for example, the outliers, the interquartile range, and so on. But that's not the only way. So if someone asks you to visualize a specific part of the data, you can try different options. And different visualization tools will give you different perspectives of the same data, which will depend on how you use it. So again, we come back to the 4 spirit of the course. Whatever we learn over time, it's up to the decision maker or the data analyst or whatever you call itself to act on the and what you want. It is very like that a student is a very powerful, like general document, very powerful. But you just likely to do something, then it's not okay. Thanks. What is context? What is this problem? And this is about the health feedback. How many of you don't have to generate it before, but you know the word. I forgot what it is. At least you see something like it. Well, that's anyway, right? We will try to solve it together. So basically, a histogram is like a frequency plot or a table, which will divide a numerical category into different ranges. For example, here, from 0, 0.53 to 2.13, that is the range. And sometimes we call that big, like BIN. Then, after separating the beans into equal sizes, we count in the data how many observations belong to that input. For example, here it's around 10 in this range, and in the next bean, in the next range, there are much more than 160. So after counting for each bean, then we visualize the height of the bar at the frequency that a certain range of values will give us. Working with us why is this useful? Because visually speaking, you can get a very immediate understanding of the distribution of the weight. Right? Because let's first generate the histogram together. Again, we select the column of data. We go to insert. Usually we should try at least the recommended part. Okay, there's a third one. So again, there's no title or no legend or no whatever. Let's forget about it for now. But let's take a closer look. So Excel will help us automatically decide the bean size and the bean width. And then it will help us count and visualize the overall width. Again, if you are very, very familiar with probability and statistics, you can think of this as a discretized version of this expression. Yeah. If you are not familiar, then forget it. You will understand from the data perspective. So from this, you can understand for each income interval, for each income region, you can roughly divide it to low income, medium income, high income, and sector. How many observations in the data set appear in that region? Again, later we will talk about if you want to change the number of beings to begin with, we can manually do that. But let's wait for another lecture. This is histogram. Well, naturally, you will have a question. Well, what is, I mean, this is obvious. This is very obvious. Very, very obvious. Because Excel will, depending on the numbers, on the values, it will automatically help you decide the being. What if you want to manually specify things? Instead of 0.53, 2.13, which is a bit random, you want some integer value for whatever breakpoint that you specify. How do we do that? So we can go to the next tab. This is one way to manually do it. You can list down your being breakpoint. For example, we want the breakpoint to be 2, 4, 6, and so on, which means that we care about how many people have hourly wage. How many people have hourly wage? So again, this is our first lecture that remember to take all the structure. But you can take a look at this example how we utilize different functions. Especially you can achieve this by this outcome. You can achieve this by using two different functions. One is called count. Well, by the name, so this function will help us count how many numbers in the data in the selected rate satisfy the criteria. What criteria is the criteria satisfied? That's it. So it will count. It turns out that only 12 observations in the weight column have values related. And similarly, we can count how many are between 2 and 4. What does it mean by between 2 and 4? It means 4 or 4. Well, I understand some of you, if your first time using Excel, you get panic already because it's like too long. Sorry. We will follow this, but also after that, feel free to check any large code. You don't have to follow me on this. It's incredibly fast. Generate a topic. One thing about this part of that, you're not happy with that off because like so remember, it will take the memory of all three. This is what we're trying to count. Again, I'm not trying to teach you how exactly the function works. That's okay whenever you have the general practice and it also different text. It will even provide you with the exact same, this is supposed to be the exact same form of the so this is how convenient this is. But again, this is slightly different, but both will do the same sort. So this is the other method. Using continuous function, we're not going into details again. So if you are a little bit overwhelmed by this expression, don't be. Leave it as it is, because we are going to introduce another way to do it. Using frequency function, which also like compiler also suggested. And you can see we are generating the same output. So using two different functions, we are generating the same output. So generally, this is true for any data analytics task. We usually do not have only one single threshold. Sometimes multiple approaches or different results, and they are based on very possible. So let's see. These functions again are not specific. It will apply to a range. So the first thing we need to do is select the output range. Suppose we are trying to generate the output range. We are trying to generate the output range. First, we need to select all the empty range that we want to output. In other words, this function does not generate a single output in a single cell. It generates in multiple cells. So that's why we need to pre-select all the cells. After we select all the cells, same way, we type in the function name, because only the first three letters we know have to fill in the name. And there are two things to be selected. One is data, and it's weight. And the other is being the range, which is exactly manually defined. Select the data rate, data, and also focus. fine. But the reason we are using full-shape center is that we need this for this is only to function that we will learn in the picture. It will deal with all the functions. You can see that after I hit Control-Shift Enter, the formula you observe from outside, it has a larger bracket indicating that it's generated not to a single cell, but a sequence of multiple. Again, if you are unfamiliar with the details, it's only our question. Don't worry. Just to showcase some of the different approaches we may adopt in visualizing. And we can visualize the histogram from here. We can also do some similar stuff. For example, generating a correlation table. Again, if you forget about the concept of correlation from your statistics course, I briefly talked about it. It's a value between -1 and 1 that measures the trend between two series of data. Closer to 1, they are more positively correlated. So if one is going up, the others you also expect to go up. Closer to -1, then their directional results are opposite. If one goes up, the others should go down on average. Only on average. So let's generate this a frequency table. Correlation table. Correlation table you can select multiple variables and it will generate pairwise. So again, you will get familiar with all these types of any get overwhelmed. Let's go to data. And we will use the data analysis. But first, let's select the result. Let's select data. Say we want to generate correlated tables, computing the correlations between pairwise between the three variables, age, education, and we select first. And we click on the right side. Data analysis. This is the external tool, but for some reason Excel is very handy, very convenient. It includes the variance matrix, histogram. This is another way to make a histogram. I didn't mention. So there are many different ways to make it. A moving average, some statistical testing, but here we care about correlation. So you put correlation, and you select the input. So again, this is a separate window for us to generate the correlation table. For the input range, let's click on this little icon to manually select the first three columns. ABC, or you can type if you want. They are grouped by columns. Each column is an individual variable. And we will have to pick labels in the first row because the first row is not value. They are the so-called labels or feature names. Labels in the first row. Again, you are a bit slow. And we want to manually specify the output range. By default, it's output in the new worksheet. Okay, let's stick with it. Or you can change the output to existing range. So we can put in the new worksheet or new tab. So this will, in the new tab, generate a correlation table. Roughly speaking, as I explained, if you have a correlation of 0, it means that the two data series are somewhat uncorrelated. You cannot predict the trend of one between the other. But closer to 1, the similar the trend. So I'm very glad to see that the correlation of weight and education is as high as 0, which is already very high number. So in general, to be rigorous, we may draw a conclusion like, at least within this data set, if we want to predict a person's income, on average, a higher education, a larger years in education will lead to, on average, a higher income. I'm being very important. Again, we cannot think anything about individuals, but on average, correlation will explain. And very interestingly, observe a negative correlation between series, which is also included, right? Versus 16, most yes, then relatively the last year, POC will be spent in the working. So this negative correlation means that, in general, if one is higher, the other we expect to be lower. Right? And on the diagonal, we have the value of 1 because we compute the correlation of something with itself. They are perfectly. They are saying that it's a relative thing. Once you have looked at the example, in general, as a rule of thumb, I guess, people care about first the sign, whether it's positive or negative. Then people will try to analyze how far it is away from 0. If it's 0.1, it in general means that, okay, there's some positive signs, but there are a lot of noise. You can predict one from the other, but the prediction power might be reduced. On the other hand, if it's 0.8 or 0.9, it means that, okay, they are almost perfectly correlated. it means that you will get a lot of information by only knowing one. The others are getting. Mathematically speaking, for two data theories to be perfectly correlated, means that they have a correlation with y. It's either they share the same value or they are linearly independent, means that you can write down a linear equation using y to express it. But again, that's beyond our scope. But the intuition usually is like this exact number 0.4 does not tell us, but the cross rate that is 0.4 is but 0.5 or 0.6 a lot of things that they still have another pair of argue that they're but they're very close that it will there's usually we care about trying to get a lot of stuff then all the numbers this is and finally we have the count. Well, this is the most straightforward because so far we have been dealing with equations, right? So the last two columns which are well indicators and formally speaking we call them binary variables. We can also do some quick analysis. We can even simple, right? Because the outcome is not a number. It's either 0 or 1. Alternatively, I think the answer to the question, are you a female, is answered by either 1, which is yes, or 0, which is no. Right? So if you do a count E, again, count E on the column, how many observations at the value of 1 will be tested then the count of 1, which is 260, will be the count of number of features with each data. So this is the binary variable because everything is simply straightforward. 0 means no, 1 means yes, and when you sum it up all the y, or you simply sum it up the column, you will get a total number of numbers. Right? The interpretation is simple. Similarly, you compute the average of the column. Someone quickly. What are they 0.47? Sorry. Very good. It's the percentage of females. Roughly 48% in this data set. Why is that? Why computing the average gave us the fraction or the percentage? Well, that's also straightforward if you take the binary variable, right? Because when computing the average, only the number 1 will compute the average. 0 does not count at all. Okay. So if all males does not count, all females are counting towards the average, that will be the fraction of females. Similarly for the marriage case, so roughly 61% of the observations in the data set becomes the number of observations. So this is the convenience of the binary variable. Part of the reason why previously earlier in the lecture I said it's a good practice and it is convert categorical variables binary. The downside is that you end up with a lot of columns. MPI example, originally you have a single column. After the transformation, the data is much larger, but it's formatted. So this is first lecture. I don't want to go through any details further. I will use the remaining 10 minutes also to briefly talk about large models. Very briefly, because again, this course objective is not for you to host or deploy a large model on your own machine, or trying to understand the mechanism between all the transformers or neural networks. You can treat them as black boxes, as very helpful tools, powerful tools. It's not necessary for us to understand how exactly do they work. So a quick introduction of how the large models, often called them LLMs, work. You may find them surprisingly magic, because sometimes it will just be surprisingly human-like. But behind that, the analogy, they are just nothing but guessing. Roughly speaking, none of here is research. If you are from pure learning or CS background, many of you might not be 100% correct. But for us, for our context, so at the very basic, LLMs are statistical pattern recognition and prediction. So later we will try to explain why. So reason that. So some fundamental elements of LLMs, including think about our human when we speak and speak, they are fundamental elements of letters and words. And so how the large model works is slightly different. The most fundamental unit is it's not exactly word. Sometimes, for example, things are the most fundamental unit that makes the LLM does not behave from the most basic like so From tokens, they form. You can think of this as human beings and characters. So the fundamental version of ChatGPT, I think this is the basic version, will consist of more than 4,000 tokens, which means that they have this much space of memory for data process. So if you are talking to the chatbot, will suffice to find that sometimes they remember or require they remember your text, but this is okay. And for the technical details, yeah. The tricky part is that they are trained using very fancy machine learning models like transformers. Actually, GPT is the short for generative and either predictive. Sorry, P is for predictive, I guess most likely. And the T is for transformer, which is a special and most popular version of the neural network machine learning model. So again, we're not going to that side, but you can think of this large models as a word guessing. When it tries to form a sentence output, when you ask, okay, GPT, please write my essay, it will write an essay for you. What appears in that essay, how it's being composed, is not how we write an essay using human logic. It's using the word guess by the tokens in the system. So when we speak, when we talk about sometimes, okay, it's freaking surprising that sometimes large models behave like humans and they generate surprising results, we seem to understand what you mean. Technically speaking, it's not. It's just by statistics from the large source of data. Because what is the most powerful trait for GPT? This is from my perspective, this is the best example illustrating how a quantitative change into qualitative in many ways. They are big. Because of the huge amount of data that no single human group even process. GPT has the power, the memory of tokens and everything else to process them, so that from its past observations, like for example, Google has all the web page information, search information, it will try to guess. If I write a sentence in their system, what should be the next output? Give you an example. So this slide basically tells me that LLM does not understand or communicate with human beings in the way that we do. It's quite fundamental. So they do not have everything is cold blood math. So for the next word prediction, let me give you an example. So if it tries to generate a sentence of my favorite color is, by the statistical model, it will try to guess what it's actually. Statistically, it will base on all the information. The most probable outcome for the next word are the colors. My favorite color is black. Unlikely, but possible, very low probability. There might be a random word which is not a color, but because the probability is so low that, for example, someone made database, but because this doesn't make sense, not many people use it. So statistically, yes, we're not likely. That's why it is also what we generate. As a consequence of sometimes they can give you an impression of like that. So as a single I may be an expert in certain fields, but I cannot be all known. I cannot possibly know all the knowledge and all the information. Fortunately, GPT is closer to something that all knowing. Although some of the information is relevant, go for a field. And because they know so much and everything is probabilistic, sometimes the output they generate may inspire you. Particularly if you work in some interdisciplinary reporting groups, try to work on some field that you are not familiar with. That's where they are the most helpful. So usually speaking, when GPT was first developed, they were the best suited tasks were like identify tasks from a related field or another field, generate diverse narratives, help with ambiguity, those things. But nowadays we know they are so powerful that we are using them for everyday use. Just to share my own experience, I use Gemini on an everyday basis, but mainly for one, like an email, to express any grammar mistake and so on. Two, when I write an academic paper, I'm not a native speaker, so the paragraphs I wrote are quote unquote garbage. But a few years ago, when I was in my PhD, I paid thousands of US dollars hiring copy editors to improve my paper slides. But last year I checked, they bankrupt because of it. Nowadays, we don't need those investments. The outputs from the large models are highly professional in terms of academic. So if you haven't used any large models for whatever task, even in this course assignment, not the exam, I encourage you to at least try. But having said so, how powerful it is, I have to warn you, again, from my own experience, improve writing emails, or even sometimes helping summarize papers, very good. because of the word prediction and the unpredictability, and because of the statistical speaking, two users ask the same question, you will probably get a difference. Even for the same user, I ask the same question twice, I may get a difference, which is understandable, right? Once we know about generative prediction. So this is a warning that if you want to do some fact check, means that there's only single correct answer, and you ask a lot more, make sure to double check, because from my own experience, I asked GPT or Gemini to summarize a list of relevant papers for a literature review. Then surprisingly, 90% of the papers are made up. I cannot even find the title is so relevant. I would almost write it out tonight. But I cannot find the any text. They're all so always take the responsibility. Whatever tools they are there, objectives, how let me briefly skip the last two slides. Those are mainly for you. If you haven't used any large models, there's quite a long history, short history compared to the others. Start from GPT. Some of the popular models including Gemini, DeepSeek, which is very, very popular. So last year when I did report, DeepSeek was not even there, but it's very, very popular. And now we have the more features like related things, image generation, video generation, deep thinking, deep research, those kind of something. So you can try that. Again, for GPT and Gemini, you are a VPN user, but as I said, for Copilot and CPU are test. You don't have it. So you are to try on. So I should stop here. It's 41 already. If you have any questions, I'll be here around a few minutes. Otherwise, I will let you go. Have a lunch. Bye.